Good morning, friends. Welcome to GoOnlineTrainings.com. So today, let us understand how to implement using SSIS, how to perform incremental loading, known as a delta loading. It is also called as partial loading of the data. So normally, whenever you go to any package, the using a package, you should be able to load full load of the data to the destination table, or you can perform incremental loading or delta loading or partial loading. Okay, so how to perform full load we know. So whenever you run the package, it's going to take all the data from the source system. It's going to dump into a destination table, target table. Now, if you wanted to perform incremental loading, what are the options you have in SSIS? So we have lookup transformation you can use. We can use in SSIS SCD transformation, slowly changing dimension you can use, or from the SQL Server side, you can use merge statement to perform incremental loading, or you may write your own customized code or stored procedure, or you can have different, transformations from SSIS to perform the incremental loading. Or from SQL Server, we have set operators. We may use except, intersect, union. So this kind of a operators you should be able to use and you perform incremental loading. Let us understand what is incremental loading. So when you take, let me take a table called employee table. I have employee ID, I have employee name, I have employee salary. So when I take this data and I have one, say John 1000, I have two, say Salman 2000, I have three, Rishi is 3000. I have some data here, right? So this is my source system. So this is my source system and I'm able to perform the data to the destination. So let me copy and paste, and you think that this is my destination system, and here the name of the table is EMP dist. This is the name of the table and this is my destination system. So are you clear? So whenever you execute the data and load the data, all the data from the source system has gone to the destination table. It is fine now. So tomorrow I insert only one row, say fourth row called David, and the salary is 4,000. So when I again run my SSIS package here, the SSIS package should be able to take only the data, the extra row which got inserted here, only that portion of the code has to be, the data has to be inserted in now. But the SSIS is not going to do, because SSIS always takes all the data and it is going to dump all the data here. But if you're planning to dump all the data, the problem is that it's going to consume lots of time. So people may say delete all the data from the target table and load the data. You think if we have 3-4 rows, definitely you can do, truncation followed by loading of the data. But you think you have already copied 3 million data, you have to, copy only the extra row which is, available here. And this data is known as a delta data or incremental data or partial data. Okay. So here we have got an insert. That insert we have to, put it here. So definitely deleting all the data and loading all the data from the source system to the target will be a bad idea. So this is not the right way to do it. You have to identify, or SSIS package has to identify what is the, incrementals of the data and only take the row and it has to insert the data here. So now how does SSIS know that this is the row got inserted just now? Okay, so this is the logic we have to implement as part of SSIS package, so that you should be able to take only the inserted row that you're going to put it here. Okay, so this is one thing you have to understand for the inserts. Or somebody may come, they may update the data. For example, it is 1000 and maybe it will become 1200. So this is updated record. So whenever you run the package, the SSIS package has to understand the updated records, and only it has to take this record and it has to update here. Clear? And this is what is called, incremental loading. So you may have delete. So if anybody is deleting the data here, and only that record has to be deleted whenever you run the package. So whenever people are doing insert, update, delete data in the source system, whenever you run the package, and the package should have, intelligence to identify the inserts and the updates and deletes, and it has to do the actions on the target table. So how we can perform the incremental loading? So that is when you have to use this kind of an approach. So you may have lookup transformation, you may have slowly changing dimension transformation, or you may use merge or customized code or set operators. So let us perform incremental loading of the data today with the help of lookup transformation. Hope you're able to understand what I'm talking about. So every package or every table, whenever you configure the SSIS package for the table, definitely the table should get incremental loading. So whenever you load the data from OLTP to data warehousing system, all dimensional tables should have, incremental loading logic. So remember this. So the data warehousing system will have two kinds of tables. One is the dimensional tables, then the fact tables. So we're going to discuss what is the dimensional and fact table later in the data warehousing. So whenever you load the data to the, dimensional tables, all the data you have to load using incremental loading only. So incremental loading concept is very, very important whenever you load the data to the data warehousing applications. So let us understand how to perform this. So let me go. I am going to use lookup transformation to do that. So take a package and let me show you the code which I have already written. So I'm going to use a company database. So created a table called employee ID name salary, and this is the data I have just now inserted, and the data is available here, right? So this is my source data. And I have also created a target table called employee list, and which is a blank table. So execute this, and it is already there. So let me only read this. So let me read this, and let me have employee underscore list also. And when you execute both, so this is the data and you don't have any data in this table. Now I have to load the data into target table. The target table name is employee underscore list. Fine. So I have both tables are ready now. So I'm going to perform incremental loading. So what is that I'm planning to do? Let us understand now. So we remove this data first, and let us also remove all these things, and let us make it to 1000 only. This is the initial data, right? So this is what you have to understand here. So I don't have any filling. Now what is going to happen? I first implement a lookup here. Okay. So lookup means every lookup should have a reference table, right? So I'm going to use a lookup transformation. So lookup transformation should have a reference table. Now for the reference table, I am going to give as this table only. This is the logic. Okay. So first I'm going to do, let me go here and take the data is available in OLADB source. Double click on this and go here and quickly connect to company database and take as an employee, and this is the data I'm going to use, and I'm reading the data. So the next thing what I'm doing, I'm planning to use the lookup transformation to perform incremental loading and take this and now double click on this So what I'm doing, redirect rows to no match output, and this is full cache. Connection is company, but the destination table I'm going to use, this is the trick I'm going to play now. And the destination is table, unfortunately, do not have any kind of a data. And this is what we have connected. And the source employee ID and the destination table employee ID, I'm going to target and click on OK. So now let us understand what I have done. So I have taken a lookup and I have connected to this destination table as a reference table. Now this employee ID and this employee ID I'm matching. So here I'm putting employee ID of source and I am putting on to employee ID of destination. So this is what I am mapping here. So you're able to understand, right? So in the lookup. So lookup is taken the employee destination table as a target table. Now it will compare. So first time it will compare one with nothing is there. So this record will be unmatched data because you will get matched data, unmatched data in the lookup. So I'll say redirect rows to no match output. So initially you don't have anything data. So the one will get compared with this, but nothing is there. So this is a unmatched data, and two also you don't have any, nothing is here, and this data also will become unmatched data. So this is also unmatched data. So when you compare the first time, all these records will be part of unmatched data. So you have to take all the unmatched data and that data you have to give it to the OLEDB destination. Okay. So this is what you have to read. Okay. Now you're reading the data with the OLEDB source and using this data, you're performing a lookup and you're sending the data to the OLEDB destination. So all unmatched data. So all these records will come. So all this record will go to unmatched. From that, it's going to go to the destination. So destination means again you have to give. This is what is your destination. So here lookup table is this table only and OLEDB destination table only this table. So it will compare this data and this data. I don't have any data here. So all of them will become unmatched data. So this is what is the logic here. So you have to use lookup and get the unmatched data. Now click on this. Now when you see, this is my destination table I have used as a reference table. When you columns, this is my source data and this is my target data, and never check these columns because I don't want to get any data from the destination. So many people will do this mistake. It should not check this. None of the columns should be checked. Remember this, because only for the comparison purpose I am planning to put employee ID. This is source employee ID. This is a target, the destination employee ID. So be clear on this. Now, what I'm planning to do, take the OLEDB destination and try to put here, and what data you wanted to send. Very, very important. So don't take match data. You have to take lookup no match data. Okay. And double click on this and go to company database. We have a destination table and click on mappings. So I don't have any data here as of now. So this is what is it's going to happen. So all the data will get inserted here. So let me have a insert. So all the data will get inserted here. So this is what you have to understand here. Clear? So let us see what is going to happen there. Okay. Now let me run the package. When I run the package, all the data from the source system, it will compare, and those three rows would have been compared with the target, and no data is found. All the unmatched data would have gone to the destination table. Now you have the data here. Have you seen the source and destinations are perfectly fine. Now what I'm trying to do, let me increment one more row here. So the fourth row I'm planning to put in the source system is for, say, David. Okay. Now the salary would be, say, $4,000. So let me insert the data. So insert it. Now when you go to these tables, so the source has 4 rows and the destination has 3. Now what is going to happen? Let us compare. When you compare 1 and 1 will get compared. So I'm not going to capture the history of the, I'm not going to capture any kind of a matched data. Only I am getting the lookup no match output. So according to this, all the data is now gone here. Okay. Now what is going to happen? 1 and 1 is getting matched. I don't want to catch the matched data, and 2 and 2 is matched, and 3 and 3 is matched, and fourth record is unmatched. 4. So we're talking about David here. David is going to be there for the 4,000. So when you it's 4 and there is no 4 here, so only this record will be part of unmatched data, and that will be given to this guy. This guy is going to insert here. That's it. So you will get this record on only whenever you insert here. So this is what is called incremental loading. So we are not taking the matched records. We are taking only unmatched records. So this is the trick you have to understand. And when you go here and save and execute the package, it will read 4 rows, but out of that, it is going to identify only one row as the unmatched data, and that row only is going to go. So when you go here, now you're able to get the fourth row David also here. So are you able to understand? So this is how you have to understand the incremental insights. Clear? So now what I'm going to do, but what about updates? For updates means all the matched records. For example, John's salary would have become 1200, right? So now what let us planning to update something, update EMP and set salary to say 1200 bucks and where employee ID equals to 1. So the John salary will become say 1200 bucks. Now when you execute these two statements, I have 1200, I have 1000 here. So definitely there is a change in the source. So this you have to target now. So how to target this? Now what we're going to do, so whenever you have unmatched data, we'll take care of insets. So here we are using only the insets logic. So but what about update? For the update, you lookup has to capture the matched data also. So let me get the matched data. So lookup will give you unmatched data. Lookup will also give you matched data that you have to capture. When you take this data, it is already gone, right? So matched record means everything is now matched. So all these records will be coming to the matched records. Let me put it here. Okay, because when you say lookup is matching 1 and 1 and 2 and 2, 3 and 3, all the data will be coming as a matched records here. So now the data will be here in the somewhere in the RAM because it has to come from the source. Now let me take that matched data. What I'm going to do, I am going to update. So for the update purpose, I'm going to use a command called, so there is a command called here OLEDB command transformation runs a SQL statement here. So if you wanted to perform a SQL queries, if you wanted to write, so you have to use OLEDB command here. So let me take, so take all this matched data and give it to this guy. Okay. But now I wanted to, for example, somebody has updated this to 1200. Now, because of 1 and 1 is matching, so you will get 1200 here. Okay, now you'll get 1200 here, and now you update this data with this data. So you update John to John and 1000 to 1200 for one. So take this record and take this record. So for each and every record, you're going to update here. Okay, so whether it is modified or not, all the records are going to update here. This is what is the a bad logic, but still you should be able to update. So how can we update? We have to update this table only. For updating, you have to write this statement. So you have to say update emp underscore dist table only. Okay. And set what all we have to set? Name equals to, you have to put like this. What is the meaning of this? The question mark means this data. The first row of the John is going to go, and this is what is the name, and we have to say salary also equals to this, and where employee ID equals to question mark. So what is going to happen? For the employee ID, one is going to be, placed here. This one is coming from this. And John will be placed in the name and 1200 placed in the here. And you're going to update this table. So this is how the first record and the second record. So these are the parameters. So parameter 0, parameter 1 and parameter 2. So this is what you have to understand. Okay. So let me take this command, so copy and go back to your package, double click on this, and here connection manager where I wanted to go and do updations here, click on this company and click on the local properties. When you come down, there is a SQL command here, you have to copy and paste. That's it. Okay, so when you give this kind of a question marks, and here you have to put column mappings. So here you will get parameter 0, parameter 1 and parameter 2. What is a parameter 0? This is your parameter 0, param 0. Okay, and this is your parameter 1. And the last one, the last question mark would be parameter. You have to neatly give. So parameter 0 means name. So you have to take as a name. So parameter name. And parameter 1 means according to your salary. So here parameter 1 means salary. And parameter 2 means employee ID. So parameter 2 is employee ID. So this is what you have to map. Now what is going to happen? So when the matching is happening, this will get the data and send it to down, and this is coming down. Now when it's coming down, so this matched data we are giving it to the OLEDB command. So OLEDB command will take a row by row. So it will take this row by row. The first name equals to here, it will put John. Okay, it will put say 1200 here, and for the employee ID equals to 1. So the employee destination table will be updated. Now it will become John, and here you will be able to get 1200. That's it. So it will take one more row. So for the one more second row, it will take second, you have Salman and 2000, and employee ID will become TC. Whether it's updated or not, we don't know, but all the data will get updated. So what is the problem in this? It does not know that only this row is supposed to update, because remaining data is the same. All the columns are matching here, but still we are updating. That is the problem in our logic. Okay, but as of let us see and click on OK. And now let me go here. I have some kind of a updation have done. 1200 we have here, we have 1000, and there is no extra inserts in the source. Let us quickly run this package. Go here and start. So it has sent no rows for the insert, but all 4 rows have been updated here. And stop. When you go back and execute this, you should be able to understand 1200 and 1200, and unnecessarily this data is also getting updated. Okay, but only if it is updating only one row, that will be good, but it is updating the remaining data also. So that is one negative point in this. But this is how you have to perform incremental loading. So when you go back here and let me increment this to say 1300. Now it is again incremented for this salary, and let us see what's going to happen. Now you have 1300, you have 1200. Now you may have, one more guy salary also. Let us increment. So for this guy also, let me make it to 2300, and it is what is happening now. So two records got updated. Let me just go here and start debugging this. So whether it is a two row, four row, we don't know, but all the data will get updated here. So when you go back to this solution, you're going to understand everything is in sync. So you may update the name column only, but only thing is that you have to understand the primary key data should not get updated. If you're updating the primary key data, the incremental loading is not going to happen in any sense. So remember this, primary key has to be there and the primary key data should not get updated. What is the meaning? You cannot change 1 to 10, 2 to 20, 3 to 30, 4 to 40. So if you're going to change the primary key itself, then incremental logic will not fail in any ETL, not only in SSIS. So the prerequisite for this demo is you should have a primary key in the source system and the primary key data should not get modified. If you are modifying, then you have to do only one thing, delete all the data here and load the data fully. Truncate the data, load. You cannot perform incremental loading if you're disturbing this column value or if the source is not having any kind of a primary key. The solution which we are talking about is based on the primary key only. Remember this. Clear? Otherwise, your solution is not going to work if you don't have the proper primary key in the source system and the destination system as well. Remember. So now in this demo, there are two issues we have to understand. One is we are using OLEDB command transformation. The second thing is unnecessarily we are taking all the data from the source system and we are updating it. If you have 1 million data, but out of 1 million data, one or two rows are getting modified and you're supposed to take only those two rows and update, but we are updating all the data. So according to our logic, that is also one mistake. The second issue is that we are using OLEDB command. OLEDB command is very slow. So update all rows. This is one issue because when you update all the data, you have 1 million data there. It is going to take lots of time. So this is not the right thing. So updating all data is one issue. Second one is we are using OLEDB command. So OLEDB command performs row by row operations. Row by row operations. Because of this guy is a bit slow. Okay. When OLEDB command, when you implement for the large amount of data, for thinking about 10 million data, 20 million data, it will take minimum 1 hour or more than 1 hour it will take to dump all the data, all updates. Okay. So one problem is this. So definitely OLEDB command is not very good. So instead of a OLEDB command, we can use executes equal task to perform the same thing. But unfortunately, that is available in control flow. Okay. So why OLEDB command is bad? OLEDB command is going to be bad because it's going to perform row by row operations. So instead of a OLEDB command, we can use executes equal. So executes equal task is a batch command. It is going to take at a stretch 15,000 rows and is going to update. But here read data update, read row update. So it is very slow. So these are the big issues performance point of view. Okay, so to overcome the above issue, what I'm going to implement, I'm going to put one more lookup here. So here the point is I wanted to understand the data which is got updated. Okay, but not all the data. So what I'm planning to get the lookup matched data. So matched data means we'll get all this data now. Now I'll put one more lookup here. So one more lookup I'm going to put, and in that give all this matched data. But in that what I'm trying to put, you compare all this column with this column and this column with this column and this column with this column. And the second lookup, I'm going to compare all the columns. For example, now it got updated to 1300. Now because of this, you will get 1300 here. and remaining data did not get updated. So because of the first match, because first match 1 into 1, so only one column. So this is a matched data. So 2 and 2 and 3 and 3 and all the data will come here. In the second lookup, what I'm going to do, I'll take this and this. So row by row comparison I'll do. Entire row and entire row I'll compare. So 1 and 1 compare, John and John I'll compare, and this I compare. So this will become unmatched data because 1200 and it does not equals to 1300. So this row and this row is not equal. And this is what is called unmatched data. So I compare entire row, all the columns I'll compare here. So here trick, you have to compare all the columns. All columns you have to compare. So here we are comparing only employee ID equals employee. Here we have to compare employee ID equals to employee ID, name equals to name. So you have to salary equals to salary. When you have thousands of columns here, this is one thing we have to understand. Okay. So when we compare, you will get unmatched data because matching, everything is matching means you leave it because this is 2000 and this is also same. Leave that row. Only take unmatched data. So from this lookup, I'm going to take unmatched data. That unmatched data means now I should be able to get only this row because of this data here. So try to understand. So this is what we're going to control. So because of the unmatched data, I am going to take only that data. This data you have to give it to this guy. So that's it. Only this lookup you have to put it here. So go back and this is lookup matched data only I need to have, and control C, you can copy the same lookup and paste. Okay. And take the lookup match and double click on this, and the connections you will have same connection only. You have this data already. And the columns you have to have name and salary and salary. So all the data you have to compare. And same thing, no match. Take the no match data, you have to send it to. So what is going to happen? Matched records will go, but if something is not matching, for example here, if everything is matching, I don't want to send it to the below to the end of the target. So I wanted to take only the unmatched data. So I have only this row because 1200 and 1300, only that row will come here because remaining data is not going to be changed or changed already. So there is no issue. So here it will get filtered. Clear? So now you go and you get the data and you execute the data here. Now, unfortunately, I did not update anything here, but now let me go and increment the salary of 1. Say we have 1300, right? So let us make it to 1500. Okay. So now it is 1500. Now you take this row. So this is a mismatched record. So let me go here and execute. So 4 rows have been read, but unfortunately you're able to get one row here. Have you seen? The one row only came here, and you just go there and execute this. You're able to get only that data. Okay. So this is what you have to understand. So if you're not able to see, let me put here 1700, execute. Now I have 17, I have 15 here, and go back and start this. Have you seen? Only 4 rows it is reading, but unfortunately you got only one row that is got updated here. Clear? So this is would be a nice thing to understand. So when you go back here and you're able to get only that record. Have you seen? Now I don't want to put OLEDB command because which is very slow. Instead of that, I wanted to use the execute SQL task. So what I do, I remove this and I replace one more destination here, and I'm planning to keep OLEDB destination. So take all this updated data. You have to no match output. You have to simply double click on this and create one more table here. The table name is called employee stage, EMP underscore stage. Okay, so all the updated records will be going to the stage table, and this is what so we are not going to update. So all the data we are simply putting it in a stage table. The stage table name is, so let me put here, this is a stage table. Okay, so as of now I don't have any data, it is a blank table. So let me put some, say 1800 here, only this row will go here. So I have these two rows but in the stage table I don't have any data, but let me run the package. So one row got inserted in the stage table also. It is not updated. When you go to the stage table, you're able to get the data which got updated, 1800. Okay. Now using this table data, you have to update the target, because when you see the target is not updated, because 1800 you have, but 1700 only you have. So you have to take the stage data, and using this table data, you're supposed to update this. So how can we update the data in one table using another table concept? So let me take and write it here. So why did we remove OLEDB command? Because of it is performing slow operations. I don't want to use this. So let me update. Okay. So what I'm going to update, employee underscore dist. Okay. And I have to set all these things, right? So what is the command I have to give? I have to give a command called from employee underscore dist as a join, and I have to copy this as B. Now on A dot employee ID equals to B dot employee ID. Now what is going to happen? You have only one row here. So this row and this row we are joining. Okay. When you join this and this, so 1 and 1 will get matched. So 1 and 1 will get matched, and you update this John with this John and this salary with this salary. So how to do that? So you have to say update A. A means what? This is the A. Okay, update A. Set, okay, set A dot name equals to B dot name, comma, A dot salary equals to B dot salary. So this is the right thing to do it. So using one table, you are updating another table. What is B salary? B salary is, this is B. B salary you are updating to A. B name you are updating to A. So this is the command you have to write. Okay. So you should not put the name, the table here. You have to put the alias. So take this and you can simply copy, and you can run away. You can run this now itself. So let me run and execute. One row got affected, and now you can execute and see you got 1800 here. Okay, now you see it is working fine. So it is 1800, it is 1800, but once it is done, what we have to do, we have to delete. So delete from the which table? Stage table. I don't want to keep any data because next time it has to be empty. Okay, so these commands I wanted to copy, okay, and go stop this, and once the data flow is over, so drag and drop execute SQL task And once the data flow is over, you have a staging table. Go here and connection, new company, and this is where you have to paste. Okay, so you have to update, then you have to delete the records from the staging table. So done. Save and execute. So all the data, you don't have any extra data here, but if you get some data, it will get updated. So now let me go here. Let us make it to say 1900. Now got updated. Now when you see the data, you don't have any data in the stage table also. It is blank. But you have the matched records 1900 and 1800. Now you go back and execute. When you execute, so it is doing the same thing. So when you go back, it would have taken one row. The one row would have gone here, and from that, so now when you see the data here, it is now 1900. So this will be blank for you. Okay, so we are using a staging table and we are able to perform this logic because why are we using this? The question is very simple. So execute SQL task is very faster. When we have lots of data which is getting updated, millions of data when you're getting here and you're loading all the data to the destination table and using execute SQL task you're updating because this will give you immense performance. I have tried and tested. So 1 month back we were running approximately 15 million data which was taking 1.5 hours to update, and when we replaced with execute SQL task we are able to do in 17 minutes. Okay, less than 17 minutes we are able to get 15 million data and we are able to perform incremental loading. So this is definitely a huge performance improvement technique. Instead of using OLEDB command, so you create a staging table and keep the updated data. Using the staging table, you go to the execute SQL task and perform these operations. But instead of using delete statement, so let us use the truncate statement. So truncate statement will give you immense of, this one, performance improvement. So let us put truncate table instead of deleting. So this one change we should control C and go here and we have to put this. Okay, so without go you cannot give one more command here. So when you wanted to give more than one command, so use go as a batch terminator, so that's going to work for you. Clear? So this what is the incremental loading of the data. It's working fine. So you can have like this. Clear? So this is what you have to increment and you have to implement and you have to do it. So very simple demo. And anyhow, delete commands I did not do it. You can now think of the logic for the delete command and you implement. So normally dimensional tables should not delete the deleted records because the data warehousing systems should capture the history of the data. So even though the source system does not have the deleted records, the destination system, the data warehousing systems should be implementing the history. So it has to capture the history. Even though you delete in the source, you should not delete in the data warehousing systems. Normally in incremental loadings, you never do the delete. But if the customer says, I wanted to have deletions also, now you can think about your own logic and delete. So however we are doing it, and you should be able to do that also. Clear? Do you have any questions, guys? So is it fine or not? So we're able to perform the lookup operation with the perform incremental loading. So next time we'll see, slowly changing dimension, the next one. Yeah. Any questions you have?